Hi everyone, welcome to Completing the Square. This is part one, and we're going to be talking in the first part of the square root property, with the square root property, and this is Nicholas, JMV, so let's go ahead and get started. So the square root property is a pretty simple property. Basically it says if x squared equals a number, then x equals plus or minus the square root of that number. We want that number to be greater than 0. It doesn't have to be, but we'll talk about complex numbers soon enough. So this is the idea here. And so let's look at, we've got two really simple examples, but let me show you. We've done some factoring, and in Algebra 1 you've also done some factoring. But let's say we do have, let's solve this equation. And by solving this equation, we mean we want to find the x values. So what happens if I brought it over the negative 16, okay, the minus 16, and we had something equals 0. That's how we want to solve that. We want to know, okay, what y values do we get 0? Okay, so if I factor this, I would get two numbers that multiply to be negative 16 and add to be 0. Okay, there's no b term there, would be this. Okay, and this idea is the zero product property. So what I'm saying is that if two numbers product is 0, one of them has to be 0. So we set both terms equal to 0. And when we solve that, we get x equals negative 4 or x equals 4. So there's the idea behind that. There are two numbers squared that give us 16, right? So the shorthand way with the square root method, or square root property, is just saying x squared equals 16. You're like, awesome, square root both sides, and then x equals plus or minus 4. Plus positive or minus 4. That's where we get that. So here's the math behind it, okay? But when you square root a square, they cancel, and the square root of 16 is plus or minus 4, right? So the idea here is 4 squared equals 16, and negative 4 squared equals 16. There's where that plus and minus comes in. Okay, so let's look at example number 2, solve x squared equals 18. So I wanted to bring this up because not all of our problems are just going to be perfect squares. 16 is a perfect square. The length and width are the same, but 18 is not a perfect square. So I start off and I say, okay, x squared equals 18. So mathematically, I'm going to square root both sides. I'm like, great, cancel, cancel. So now I have x equals the square root of 18. We can simplify that to being 9 times 2. We can break that apart and say x equals, so we're going to have plus or minus here, right? We're going to have the square root of 9 times the square root of 2. Okay, mathematically, and then so that's plus or minus. Square root of 9 is 3, so we get plus or minus 3 root 2. So that's irrational, but all of our answers are not going to be perfect. So that is the idea of the square root property, just taking the square root of both sides to help us out. So those problems do get a little more complicated. So here's our first two examples. Let's go on here and see what we got. What happens if we have a trinomial now? And it's like, okay, how do we work this? So on the left side here, we're going to look at example 3, and it says solve this equation. X squared plus 6x plus 9 equals 36. Now the key here is, what are two numbers that multiply to be 9 and add to be 6? That's 3. So it's going to be x plus 3 times x plus 3 equals 36. So guess what? Two numbers multiplying that are the same, so it's x plus 3 squared equals 36. Now here comes the square root property. Square root both sides. So that means we get x plus 3, right? Because the square and the square root simplify out. And the square root of 36, that's a perfect square. You get plus or minus 6. So now just subtract 3 from both sides. So you get x equals negative 3 plus or minus 6. Okay, so negative 3 plus 6 is 3, and negative 3 minus 6 is negative 9. So our two solutions are x equals 3 and x equals negative 9. Okay? So let's go ahead and look at one more. Let's go ahead and solve this last trinomial. And this is also a perfect square trinomial. Okay, x squared minus 10x plus 25. And that equals 27. Now this is not a perfect square like the 36 was. So let's see. Two numbers that multiply to be 25 and add to be negative 10. This is going to be x minus 5 times x minus 5, or x minus 5 squared, and that equals 27. A perfect square trinomial means the length and the width are the same. Okay, so now to undo that square root, or excuse me, that square, we square root both sides, and we get x minus 5 equals plus or minus root 27. You can simplify root 27, so root 27, we'll go over here, is equal to 3 squared times 3, which is just 3 times root 3. Okay? So we have x minus 5 equals plus or minus 3 root 3. And let's bring the 5 over by adding it to both sides. Now this you can't simplify really, so we're just going to have x equals 5 plus or minus 3 root 3, and we're going to leave it. We're not going to put it into decimal form, anything like that. Okay? So again, this was square root property, and really you're just taking the square root of both sides. That's what that square root property tells you. You take the square root of both sides when you can, and you get a positive and negative root there. Okay? So if you have any questions or comments, just type them below, and we'll see you next time.